This is one of two videos that are going to talk about starting a SolidWorks sheet metal part. This one is going to be focusing on our base flange tab command. And this is more or less a fancy way of creating a extrude in such a way that we end up with a SolidWorks part. With this, the first thing that we need to do is get our commands up for our SolidWorks sheet metal. With this, we're going to right click on our top ribbon here. We can either go into tabs or into toolbars and find the sheet metal option. I prefer tabs because I like having everything up on the ribbon. You can find even more items within our toolbars if you are interested in that. It tends to be a little bit more specific, but this works just as well and has all of our sheet metal stuff up top for us. With that, what we're going to be doing is we're going to be clicking this base flange / tab command up top, which is the focus of our video. And with this, what you're going to have to do is select a sketch. Now there's two ways to use this. The first is using a sketch like I have here, where we have a completely enclosed object. We have to be careful. This is not going to work like it would if we were doing just a basic extrude. If I had some other square right here such that I don't have a single united entity, it's not going to let me do it. So if you wanted something like this, make sure that maybe this portion is hidden lines so that we only have our little square with a nibble taken out of the corner. Otherwise, it's just not going to allow you to use this command. But what we're going to do is we're going to go ahead and click on our part, and it's more or less just going to extrude that square for us to a thickness that is going to create a overall piece of sheet metal. Now with this, there are a couple ways that we could define how big this sheet metal is, how thick it is. The first couple up top here are going to talk about our sheet metal properties being pulled in from something else. So this top one is talking about if I want to pull it from the material settings that I have for my overall part. The bottom one is talking about using sheet metal gauge tables that exist in SolidWorks. I am going to avoid these because I work with multiple different versions of SolidWorks for my classes, and don't necessarily have everything available from one version to the other, which can cause some issues in the long run. If I did want to use them, it's just a matter of clicking on them and selecting the gauge table, selecting what gauge we want for this. Alternatively, what you can do is you can actually manually set this. So these parameters down here, I have the ability to set the thickness of my sheet metal right there. And I have the opportunity to mess with a couple of other commands that are a little bit more detailed than we're really going to talk about in this video. So with that, I set my sheet metal thickness and I have created a part. So I hit the check mark, and basically it's just an extrude to the thickness that I want it to be here. But that thickness is defined by sheet metal, and I have created this piece as a sheet metal part. So all of my sheet metal properties are stored within that first setting piece, and then the base flange where I actually created the sheet metal piece is right down there below it. This is where I would go if I actually wanted to edit that command, if I wanted to change some of those settings after the fact, such as changing that thickness or something along those lines. With that, this is one of two ways that I can do this. The second way is going to be a little bit more like our thin extrude. So we had the thin feature extrude within our extrude commands. So with that, what we're going to be doing is for a thin feature, we were focusing on lines. For our thin feature version extrude of our sheet metal, we're again going to be focusing on a line here. So I've got a series of lines that I've selected. Again, you notice that I didn't click on all of the lines that I wanted to select. I clicked on one and it chose everything here. I had lines all the way like so. This is again because every solid line that I have in my drawing, when I go into my base flange, is going to be used by SolidWorks in some way in order to create this. So If you've got extra lines in there that you don't want becoming sheet metal, make sure they're hidden lines. With this, you're hopefully noticing that I've got a lot of the same components at the top because it's still the same command. I have a couple of extra pieces here. So these guys, well, not entirely this, but this guy right here was our thickness that we could set before. This guy up here is not that thickness. That is how wide we want our sheet metal to be extruded to. So when we originally drew it, we had a square, and we knew this was exactly the shape that we wanted. In this case, we just have a line, so we know how wide that line is going to be when we turn it into sheet metal. And we can kind of see that in the preview here, where everything is going to become yellow. We've got a long piece, and I have the same options that I had before for extrudes. Again, there's this gauge table option right there that I could use. We're not going to be using it for my class. And now I have an extra piece here that is going to do with the bend radius of all of my curves in my part. So currently I've got a very small bend radius. There's not a ton happening here. I switch it and you're seeing a bit bigger bend. I make it even more ridiculously large and we're seeing an even bigger bend. So you've got that giant bend happening there versus a smaller bend here. I have the opportunity to change that, and changing it in that first piece that creates everything should change the base values for my sheet metal overall. One last thing is when we created the sheet metal, it created 3 pieces. We talked about the first 2. We talked about sheet metal, which is going to hold our sheet metal properties. We talked about base flange, which is the command that was used to create it. And it created a suppressed thing at the bottom called flat pattern. And that flat pattern is why we use this command. It might be a little bit easier to make these quickly, but the flat pattern is the real nice thing about all of this, because when you're actually using and making these parts and using these drawings, you want to have the ability to show the original piece of sheet metal before I went and I folded it across here in order to create the angle, and I folded it across here in order to create the angle. Folded across here. So I folded all these pieces. But overall, I basically have a flat piece of metal that I have made all of those folds in. And I want to be able to go through and I want to be able to take that and flatten it out and show what my flattened out version looks like. So with that, I can unsuppress my flat pattern here, and it shows my entire piece as a single piece of sheet metal. This version is not terribly interesting because all I have is that original base flange. However, as we add extra pieces to it, which we can do because we have a sheet metal part, it's going to allow us to use all of these different options here, plus all of these, so probably could have circled a little bit more there. But with that, I have the ability to use all of those, and I have the ability to then flatten all of those into a pattern that I can use later along the lines. So that is one of our 2 ways in order to create a sheet metal part, and a little bit about why we're doing that. So hopefully that was helpful. See you next time.